Hello, everybody. Welcome to the third session in the Advances in Research and Innovation stream of the SNOMED CT Expo 2023. My name is Rory Davidson. I am the Chief Information Officer at SNOMED International. I will be moderating today's session. All questions will be answered at the conclusion of the presentation. Online attendees, please use the Q&A button to type your questions to presenter, and everybody in the room, you know the drill, the microphone's at the back by the camera. I'm now very, very pleased to introduce Fuad Rahman from Howsam Consulting, who will be presenting Predicting Risks of Miscarriage and Preterm Birth using SNOMED CT. Fuad, please go ahead.
Thank you very much. So I don't know if everybody here attended the last two presentations, but if you did, then my presentation was perfectly placed. And I thank SNOMED CT organizers who actually taken care of that. Because of two reasons. One is that I don't go into any detail about what I've done, and the two previous presenters have done a fantastic job of talking about the basics, right? Because I wanted to focus on the kind of the 800-pound gorilla in the room, which is in the era of GPT or Chat GPT and all these other generative models. Do we really have a place for tagging systems anymore? And that's a very complicated question and very loaded question, because we've been building these tag systems forever, and we know that these systems are very effective. But now we also know that a very large language models like ChatGPT can do wonders by just consuming data and crunching it down into a model. So the question is, do we have any value in manually using, experts in creating these maps anymore? That's a big question that we need to start looking at. It's a very nasty question, but somebody has to start looking at that. So I thought it would be nice to start at that. I have a background in natural language processing, and I've been working on natural language processing for about 20 years. So I know all about processing structured data and unstructured data, and I know all about tagging, and I know about all extracting information, doing mapping, and all that stuff. And then obviously in the last 3-4 years, everything changed, right? When I did my PhD in the late 90s, I wrote my own neural network. Now you don't write neural networks anymore, right? You have things available. So the question is, what can we really, is there any value that we need to really, we can derive from existing systems that these new systems can make use of? And that's kind of the question that I want to address today. I mean, it's a very early attempt at doing this. But I think you're going to see some interesting results that will come out of that. So this is actually a lot of universities has worked together into this, as you can see. So I'm not going to go into individual details, but as the case is a collaborative project over 3 different organizations. So let's talk about a little bit about the background. What we wanted to do is to find or identify a particular project, a particular issue that we can apply. So this is a very application-oriented investigation, and the idea here is that if we want to identify or predict pregnancy-related issues, normal and abnormal in patients, then can SNOMED CT help the generative AI to do better? That is basically the question that I'm asking. So the question is, so how do we do that? All right. The initial thoughts were like this. The initial thoughts were that we have a SNOMED CT knowledge graph. We have free text from clinical notes. We can extract the relevant information. We can actually then, add the concepts that are already identified in SNOMED. We can actually then, tag these notes and then we can use some sort of a tagging engine, some sort of a learning engine to learn from it, and then we can do something out of it. That's kind of the initial thoughts, right? And that's probably the kind of same initial thoughts that any project starts from. Then we start thinking, okay, so now that we have ChatGPT, how does this initial thoughts can be implemented using that? Right? So what we did is that, okay, so we need databases, we need data sets. Can ChatGPT help us identify data sets? We have issues like normal issues and abnormal issues. Can ChatGPT help us do that? So the first step was, can we identify what are these issues related to pregnancy, right? Or complication, positive and normal and abnormal complications. So that's what question number one. Question number two was, can we then actually take that to identify, in random or not random, but in test cases, if these complications exist or not, right? And then somehow create some sort of a accuracy matrix out of that. And then the next step is, can we then change that somehow using knowledge out of SNOMED CT and redo the experiments, right? And that's the most critical part here, right? Can we then extract not only just the complications, but details of those complications using SNOMED CT, using ChatGPT, and then use ChatGPT to identify what's going on here. So it's in a way an integration of SNOMED CT knowledge into our classification prompts, as we call it, right? And this kind of changed the way we designed our investigation, because as you can see, the almost entire left side of this graph or configuration can now be implemented using different versions of ChatGPT. Okay, so let's go through them one by one. Dataset generation. So the challenge was, can we generate the most common normal and abnormal complications related to pregnancy? And you can see two prompts that we used for ChatGPT. Again, I'm not going into any implementational details. Thank you, John and Anthony before me, who went in detail about this. So hopefully, in the room, you guys all understand what we're doing here. But the prompt was simple. Write 10 abnormal critical cases related to pregnancy issues, or write 10 normal cases of pregnancy issues. Very simple natural language, right? Directly to ChatGPT, and it does a pretty good job. It comes out with 10 complications, which are normal, exactly on the. So the normal ones are on the right side, the abnormal ones on the left side, as you can see. So what we did was, we want to generate, about 100 notes for each of these, so about 1,000 notes. And we want to generate about 10 notes for the normal ones. So we are talking about 11 classes. So the idea here, I'm sure you're all saying, what is Fuad really talking about? What is he classifying? We're actually classifying those 11 classes. So 10 abnormal classes, one normal classes, one normal class. So in order to do that, what we have to do is we obviously have to create some sort of data set. And Anthony, for example, used real life data. And I decided not to, right? We decided not to. We said, can we actually generate data using ChatGPT? Because I know what kind of notes I'm looking for, right? What kind of data I'm looking for. Can ChatGPT actually build me fictitious patients which have this kind of normalities, normal or abnormal complications related to pregnancy? And it can, after some experimentation. Obviously, it's not as simple as I'm showing here. It takes time. This is about 6 months worth of work, as I'm showing in 30 minutes. But we were able to come out with some prompts that ChatGPT can handle and does a pretty good job in building us artificial patient notes. And the prompt that we used is something like that, we have assume that you are in a hypothetical medical data center and you ask, your task is to provide a concise clinical note for a woman who had the following pregnancy issues, and then we list the issues. That's it. That's all we do, right? But then towards the end, we basically say only provide symptoms that can lead to this issue, right? And then we say what it issue is. And it was able to generate pretty good. And we went through those generated notes one by one, just to make sure that it makes sense. We showed them to doctors just to make sense it makes sense, because we're not doctors. We're the wrong type of doctors, PhD doctors. They said, no, it looks, they look like, they sound like actually it's written by doctors, There's some weird English there, but doctors write weird English, right? That's, it looks pretty normal. So what we did, we took that 1100, notes, and we split it into 70, 20, 10, which is the train, test, and validation, ratios for our experiments. So that's kind of the output of what we got. As you can see that, it is possible to generate. You can actually see the notes that were generated on the left first column. I don't know whether you can read it because it's too small, but I can read. Maybe try to read one of these. Patient represents with elevated blood pressure, severe headache, blah 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 blah. Right? It's just a couple of sentences. And on the right side, as you can see, that we can actually identify what the issues are. Right, and it's generated from that. So what did we do next? What we did was, now we have 3 different prompts, right? We basically use ChatGPT and we ask them to classify what is actually in these nodes. What is the principal issues in these nodes, right? Or complications in these nodes. And you'll see that there are certain changes in the prompts. And certain differences in the prompts, and based on what we actually are asking for, we'll see different results, right? So I don't know whether you can read it again. I think you can probably. If you see at prompt number 2, it says you'll be given a piece of text. Your task will be to classify the text into one of the following classes, and we have a list of classes, right? Okay, so, and when we do that, based on the prompt, right, we get different type of results. Now, this is actually very important. I think Anthony kind of mentioned this. He said that, he saw something very interesting, very, very good. He said that these kind of models can only handle things it has seen before, right? So, remember, this data is already generated by a system like that. So what it does, it only answers, or only tries to answer, or tries to identify things that it has seen before. But it depends on what is the question you're asking. It's the same thing that happens in surveys, right? If you ask the wrong question, you get the wrong answer. Which happens in politics all the time, right? If you want to get a special type of response, all you have to do, and there's been a lot of studies about that. You need to write the right questions if you want the right answers, the answers that will help you in your own political campaign, right? It's the same thing with ChatGPT. If you ask the question slightly differently, the answers are slightly different. It's a very interesting thing. In a way, ChatGPT, because it's based on human language, it quite efficiently follows human-like, biases. And Anthony talked about that too. So now we wanted to do is that the first one doesn't have anything to do with SNOMED, right? This time we said, hey, I want you to use SNOMED CT, extract information related to SNOMED CT. And if you see that the prompts are now different, that we're talking to SNOMED, we're basically saying that your task is to provide the symptoms of each of the following conditions as described in the SNOMED CT knowledge graph. very specifically, like almost I'm asking an intern to do this or a research assistant to do it, right? And in the second one, we're basically saying, give me details. If you see, not just that, but we're saying your task is to provide detailed definitions of each of the following conditions as described. The only difference is conditions, symptoms, the other one is details, right? And based on that, you can see these results that are coming out of ChatGPT. It's coming out of a list of things, right? Increased thirst, frequent urination, fatigue, blurred vision, stuff like that. All right. But if we look at the prompt 2, it's now giving you a lot of details. ChatGPT is giving a lot of details because it's been asked to give us a lot of details. And now we kind of do the same thing again. We ask the slightly 3 different prompts. We ask the same question slightly differently in these 3 different ways. And we get exactly like last time, 3 different sets of results. And here are the accuracies. And here is the most important thing. Let's look at the comparison, and that's where we're going to stop. If you look at this comparison, scenario 1, it's basically comprises SNOMED prompt information, which is basically slide 1 and 2, 11 that we showed before, right? And as you can see, in all cases, if we actually incorporated the SNOMED CT information, it does better. And if we go to the scenario 2, right, which is the detailed definitions, the first one was symptoms. This one is definitions. Other than in the second one, it still does better. As far as I know, this is obviously we have done this. We've been doing it for about 6 months, but every variation of these scenarios that we're only presenting one here, but we have taken a look at other scenarios, not only just pregnancy, because we're in the middle of another project right now in Bangladesh, where we're looking at predicting abnormality during menstrual cycles. And we have incorporated very similar strategies, and we're getting very similar results too. If we incorporate SNOMED CT in our questionnaire, in the way we actually extract information, we do better. So if we just add the both scenarios, then obviously the differences increase because we do much better. So obviously nothing, just like everything I've said here, that we get what we ask for sometimes. Obviously, I wanted to show that SNOMED does great, but I can tell you that in all cases that we've looked at 3 or 4 different cases. In all cases, SNOMED actually does better. If we incorporate SNOMED in the prompts, that when we're talking to ChatGPT in database generation, in comparison, in identification, all these cases. So as if I kind of take a step back as from a researcher and just look at it as a from a layman's perspective, I think it would be not too wrong to say that all the work that we have done on the last decades, mapping terminology, has given us precise relationships between concepts, clinical concepts. And because these models are deriving relationships from models anyway, this actually helps big time. And I think that's a fair statement to make, that if we are able to give existing data in a more organized, classified fashion that has the terminology and ontology behind it, there is no reason why it should do worse. So, and again, I don't want to do a lot of big predictions or anything like that, but what my gut feeling at this point is that we're probably going to see a lot of terminologies, not only in the healthcare sector, because my company also work in the financial sector. And on their side, they have an equivalent of the SNOMED technology, which is basically the standard financial terminologies. And they have all these tags, right? That they have about 20,000 tags that explains things like, for example, what's a profit? What is a sales number? What is your annual, performance number, whatever. And those are all defined, and there's an ontology behind it. And a lot of applications right now are using these generative models and actually seeing very similar trend that if we can use the existing, tagging based, ontologies, then we do better. So I think there's no reason to panic. I think personally because I think that we are in a really solid area where the knowledge that we have captured and codified is only going to help us down the road, not inhibit us in any way. So I think I'm going to stop there. Thank you.
Thank you very much, Fuad, and apologies for the wrong organization when I introduced you. You're founder and CEO of Aperba Technologies. Fuad will now take some questions. As a reminder in the room, please step up to the microphone if you'd like to ask any questions. Any questions from anybody? A few questions from myself then in that case. So why do you think that SNOMED CT is needed to predict the risk? You mentioned that. So what's the benefit SNOMED CT is bringing there?
I think the biggest advantage is that these models that we're using are really good at doing this. But again, it is based on what it has seen in the past. And the better relationships that we can show it, the better it can learn. So in all these cases that we have looked at so far, in the 3 to 4 different cases that I've talked about, in all cases, we have seen that if we include the SNOMED CT graph information, the model just do better. And I think, again, going back to the layman's perspective, is that I think more clarity in the relationships with each other just simply helps it to do generalization. So that's probably your answer.
Okay, thank you.
Yeah.
Hello. Yes.
Hi.
So you talked about that the relations from the SNOMED hierarchy could help in predicting, but what if the relations are not? What if you put wrong relations into SNOMED? How much will that affect the gain? Yeah.
Yeah, thank you. I think the answer is very simple. It depends on how many wrong answers you put in there. It's very simple. So if you put in a lot of wrong answers, it's going to mess everything up. But these models are extremely error tolerant, because it is not looking at one dimension. It's looking at, as others have said, 1,000 dimensions sometimes. And then it's looking at millions of data points. So if you make smaller issues, smaller errors, I don't think it will have a big impact on the performance. That's my guess. Yeah.
Charles.
Hello.
Hi, Fuad. Thanks very much. Really interesting talk. Here's a very general question to you. Have you thought at all about how you would explain what you've done here to an ordinary citizen?
Oh my God. This is the toughest question. I actually, funnily enough, this question was asked to me, a month ago. I was doing another presentation and to doctors, and they were saying, "How do you expect me to explain this to my patients?" Right? So it's a hard question to answer, but I think the best way of answering this is that these new tools are nothing but research assistants. I mean, I look at them as, I told that audience that tell them that you have an artificial intelligent research assistant who has not created anything out of thin air. It looked at previous data, previous use cases, but it did it very fast. And that's and just like a research assistant or a young researcher, they sometimes are over enthusiastic and make some mistakes. So don't take it, as a word of God. But but most of the time they're right. But you still need to verify. I think that's how I would answer that. Thank you.
Great, thank you very much. So with that, we will conclude the session. Thank you again, Phil. Great presentation. Thank you.
Thank you so much, everyone.